Okay, thank you. Kiana, is that working?
Looks like it.
Yeah, okay, so we're recording this meeting. We recorded the past one as well. And we'll talk more about how to access the meeting slides, chat log, and the meeting recording at the in a few slides, but those materials will all be available. So thank you for joining, and I'll continue. So like I said, this is webinar 2, representation of water supply and demand in our groundwater surface water model. And you're going to hear from a lot of folks from our modeling team today. Our main speaker today is actually going to be Al Preston from Geosyntec Consultants, but this list of names is just folks from the state and regional board and our consulting team who work on this project. And so you may hear from some of these other people today. We do have a lot of people on this team, and normally I'd want to hear who's in the audience too, due to the constraints of Zoom and the large meeting size. We have 65 people, so thank you all for joining. We don't quite have time to do a round of introductions. As always, you can contact us at any time if you want to follow up from this meeting, or if you have other questions, or are always available. These are our email addresses, and this contact information will be repeated at the end of the presentation. So as you hear from new people, they'll introduce themselves. Okay, and we're using the same format as last time. So at the meeting start, as you've noted, all non-host participants don't have permission to unmute or turn on their video. However, during presentations, we want to hear from you. That's why we're doing this. So during presentations, we'll have stopping points for questions, and with an additional 40 minutes for discussion at the end. So to ask a question or to make a comment, please use the raise hand feature in Zoom to let us know that you want to unmute yourself and make a comment or ask a question. You also can type in chat your question. I do request that questions are typed to everyone in chat, just so everyone can see the question. We do try and keep the conversation in, we try not to have side conversations in chat. It can happen, but we want to make sure that everyone is kind of privy to the conversation that's being had and questions that are being asked. So type a question, raise your hand. To use the raise hand feature, click on your Zoom toolbar. It should be in the bottom of your screen on the right side of the toolbar. And there, if you click on that, you should have the ability to make different reactions. First come, first serve. We are going to prioritize questions. We're going to prioritize technical questions over non-technical questions, although we will answer non-technical questions. And then within the scheme of technical questions, we're talking about water demand today, which is obviously very important, and we're going to prioritize questions on, say, methodology over comments or questions about a single point of demand. So like kind of an example is, if you have a comment or a question that, say, we're about how we're representing one well or one point of surface water diversion, we want to discuss that and make sure we get that correct. But we're going to take that after we do methodology questions, because we have a lot of people here, and I just kind of want to minimize having 2 people talking about one well while there's 68 other people listening. So yeah, we'll prioritize technical questions over non-technical ones, and methodology over concerns about single points of diversion, but we do want to hear all those comments and questions. And we'll have instructions for accessing the slides and the meeting recording in the chat log at the end. It's the same as with the previous webinar. So like it has been said, this meeting is being recorded and will be posted on YouTube later this week. And we'll have that link for you. So this is the this is the second webinar in a series of 3. And our goal with the first webinar was to provide background and catch people up on the arc of the project and give a status update, and then also present new preliminary, or not preliminary, new unpublished revisions we've made to our geologic analysis. Today's webinar is a presentation on water demand and distribution for the groundwater surface water model. And in 3 weeks, on June 9th, we'll have our third webinar where we will present our preliminary calibration and validation results, as well as next steps. So we'll be talking about timeline for the rest of the model project and how to stay involved. So definitely recommend coming back for that one. We are soliciting technical comments. Please submit them by Friday, June 25th. If you don't submit comments, but you do ask us questions during these webinars, we are recording all these questions, writing them down and thinking about them. So we just want you to know that even if you only ask a question here and you don't submit comments, we still are hearing that question and considering it. So thank you. And then just housekeeping, each meeting has a unique RSVP link. So if you want to join webinar 3, please RSVP for that one. I think I've already spoke to the kind of difficulty. We acknowledge the difficulty of providing comments based on an oral presentation. And so we're trying to help facilitate that by making the meeting recording available, the chat log available, the slides available, and ourselves. So please email us if you have further questions or feel like you need more context or anything like that that can help you provide comments to us or answer your questions. So this is today's schedule. My introduction is wrapping up. I'm going to hand it over to Geosyntec. They're going to talk about overview, demands, and supplies in the first hour. About 45 minutes of that first hour is presentation. The remaining time is questions. We'll have a break at 10:15. Geosyntec will be back at 10:30 to talk about results and a summary of their water demand analysis. And we've got a lot of time for discussion today and wrap up at 11:55. So with that, I think, please clarify what we would be commenting on by June 25th. No new documents have been released. Okay, so that's a good question. I'm going to go back a slide. So we are soliciting comments on the unpublished information, the new unpublished information that we're presenting in this webinar series. So we've made revisions to the geologic analysis. We're going to be talking about our representation of water demand and distribution today. And during webinar 3, we'll be talking about our preliminary calibration and validation results. So we're really soliciting, we're hosting these webinars because we want feedback from our technical advisory committee and from the community on any major or minor issues that you see with any of this new material. So our goal is to have these major or minor issues flagged as early as possible so that we can address them now instead of when we release the draft models, which our goal to release those is later this year. Does that answer your question? Yes. Okay. Looks like it.
Kevin, this is Dan Worth, and I'll just add again that we do plan on releasing the model and the draft model documentation later this year, and having a separate comment period once that model and documentation is out. So there will be another round of comment periods.
Thank you, Dan. Do we have any other questions? Okay, then I'm going to hand it over to Paul Preston.
Great, thank you, Kevin. Let me share my presentation.
I'll be monitoring the chat for questions.
Great, thank you. So thanks, Kevin. So I'm Al Preston. I work with Geosyntec Consultants on the PM and for this project, as well as a modeler. And as Kevin outlined, the next, I don't know, hour and a half or so, I'm going to talk about the supply and demand analysis that we conducted to basically develop
Hey, Al, can I interrupt you for a second?
Yes.
Can you please raise your microphone a little bit?
Is it cutting out again?
Just for a second. Thank you. Yeah, we know that we had problems with that last time, so we'll try and we got a new microphone.
I do have a new headset and microphone, so but definitely raise your hand if there are concerns, and I can try calling in from my phone if needed. Yeah, so the goal of this analysis is to essentially back out unmeasured groundwater pumping within the watershed. You know, there's a lot of pumping that is measured, but there's also a lot of, especially agricultural pumping, as well as domestic pumping that is not measured or estimated. And we need those for the model inputs. The goal is to back it out. So that's kind of the focus of this webinar, how we did that. So there's an overview. I'm going to back up to just a quick recap on the GS flow model. I think it's important to keep the big picture in mind. Why are we doing this? You know, where does this analysis fit into the model? I'll discuss that a little bit. I'll then, again, try to emphasize the reason why we're doing this. Then I'm going to go through the demands, and within the watershed, we primarily considered residential demands as well as demands from agriculture and golf courses. So I'll look at the data and the methods we use to quantify those demands. And we did it on an annual basis over the 24-year modeling period. Then I'm going to move on to supplies. So, you know, the two big supplies of water to the watershed is the groundwater pumping. And again, much of that is measured, but some of it is not measured. And the goal again is to try to estimate those non-measured groundwater pumping volumes. Another big supply is the deliveries from Lake Casitas through Casitas Municipal Water District. And that is, you know, that's a big source of water. They distribute water throughout the watershed. So we spend quite a bit of time and effort trying to understand where they send their water, because that clearly impacts, you know, how much pumping is within a region. Because if Casitas is sending a lot of water to a particular region, then there'll be less pumping and vice versa. So we spend a lot of time trying to understand that. There are also kind of local surface water diversions within the watershed. The good example is up in Senior Canyon, where they have 2 surface water diversions, as well as the tunnel up in the mountain that supplies water. In terms of the watershed balance, they're not huge volumes, but in terms of that kind of localized region, they are important sources of water. So we included those where they're large enough. After going through that, we're going to take a break, as Kevin mentioned, and then I'm going to present results in terms of tables of kind of annual volumes and plots of annual volumes and, you know, and annual averages. I'm not going to spend a lot of time on the tables, you know, it's just numbers, but you can kind of see, hopefully that help understand the general methodology. And we're going to go through region by region within the watershed. We broke the watershed into 5, or we broke the Casitas service area into 5 different regions. I'm going to go through each of those in turn, try to move quite quickly. And at the end, going to come back and kind of recap what we did and present the results. And also check it against some other data that we found. We found some data that we couldn't use directly on the front end of our analysis, but we can use it to check on the back end. So this is a schematic I presented 2 weeks ago. It kind of shows the overall GS flow model, and there's a lot going on. And we have precip coming in, it infiltrates, it evaporates, it runs off into the streams. It goes through the unsaturated zone into the groundwater flow. There's ET, there's discharge to and from streams. And these are the things that we're representing in the model that I discussed in some detail, you know, 2 weeks ago. And then obviously a key component is the pumping of groundwater from the basins, which in turn can affect the low flows, particularly in the streams. And again, as I mentioned, you know, a lot of the pumping is measured or estimated directly, but there's a lot that is not. And so it's really trying to back out those non-measured pumping volumes in certain parts of the watershed that this analysis focuses on. This map I also presented 2 weeks ago. It kind of shows the result of the analysis. I think it's helpful to have this in mind as I go through kind of the details to kind of, this is kind of the target that we're trying to get to. I went through this 2 weeks ago, but just to recap, there's different shaped symbols on the map and different colors. The colors respond to annual average pumping volumes. So red being high, you can see down in here, the Foster Park wells. And blue being much lower annual volumes. The diamond shapes are all in the Ojai Basin Groundwater Management Authority, or the OBGMA area. And for those, we have measurements or estimates provided to us by OBGMA. So the focus is not on those wells, but we did do the analysis up there as to kind of corroborate and confirm our methodology. The circles are municipal wells, and a lot of those correspond to the highest pumping rates, for example, at Foster Park, and also at Miners Oats. And again, we have measured data for those, so the focus isn't on those. The focus is really on these square ones shown, scattered throughout the watershed. And of the square, these square symbols, they comprise mostly of domestic wells and agricultural wells. For domestic wells, we assumed a reasonable rate, 0.5 gallon per minute, based on typical residential demand for a single family, essentially. But it's the remaining agricultural wells that we spend a lot of time to try to estimate, but based on the supply and demand analysis. So again, the key goal of this analysis is to estimate the unknown ag pumping for those wells, and including the spatial distribution. We can't just do a watershed-wide model and get a total unknown ag pumping volume and then distribute it over all the wells. That's not realistic. We needed some spatial breakdown to get accurate estimates. So the general approach is pretty simple. We estimate the demands, residential and agricultural demands. We calculate the known supplies, so in this case, the groundwater pumping that is measured, the surface water diversions, which we have estimates for, and the Casitas Deliveries, which we have estimates for, and I'll talk more about how we figured out where within the watershed they go. And then from that, we can back calculate the unknown agricultural pumping. So the Casitas Deliveries, the map on the right is the Casitas distribution system, and it's pretty complex. They deliver from Lake Casitas, throughout the watershed. The lower part of Ventura River, they deliver through gravity. These upper parts, they pump, and they have different pressure zones, which I'll talk about shortly. They also deliver water to the outside of the watershed along the coast. And there's agriculture and residences along the coast that receive Casitas water. So a key challenge in this analysis was figuring out how much water Casitas is sending to different regions within the watershed. So we can enable us to back out an accurate estimate of the ag pumping within each region. So taking a closer look, the overall approach was to do a supply and demand analysis by service area. So this map here on the right shows the different service areas of different water providers within the watershed. A couple of things to note here, that the reason we chose to use these as our kind of spatial units, if you will, is because there's each of these water providers, a lot of them have reports and information specific to them. So if we choose our boundaries to match theirs, then we can use a lot of that information. But the challenge is this Casitas service area, which is the larger black polygon, quite large, that covers a good portion of the watershed as well as regions outside the watershed. And a lot of the work was spent trying to figure out how to do budgets within the remainder of that area. And we ended up splitting it into 5 regions, as I'll show shortly. The other thing to note is the city of Ventura here. A lot of their service area is outside the watershed. The city of Ventura also gets water supplies. They get it from pumping at Foster Park and the Nye wells, as well as Lake Casitas. but they also get it from outside the watershed, pumping in the Aquifers Basin, for example. And we didn't want to kind of do a full budget for the city of Ventura, so we took a different approach with them. We just estimated how much Casitas water they took out of the system, and then kind of moved forward and did most of the balance, excluding the city of Ventura. You know, we count for it first, and then kind of forget about it as we split the rest of the water up. So that should become more clear as I present the results. This slide, I'm not going to go through it, but this is a list of the data sources that we used in the analysis. We did spend a lot of time reading reports, contacting people to obtain data, and you know, this was an extensive effort. And a lot of the reports we're going to have some published volumes for a handful of years, and we'd find another report with some more volumes for more years. So this was a large effort. So we've got a lot of reports from CMWD, hydrology reports, consumption reports, as well as their monthly well productions. One of the key ones was the pressure zone data, which I'll talk about shortly, that let us kind of understand where Casitas is sending their water. Some other ones of note, the Ventura River Watershed Management Plan was a great starting document. It really helped us understand the water supplies and demands within the watershed, at the beginning of this exercise. But it also had some useful data in there that we pulled out from different figures. I'm not going to go through this to any more detail, but there was a lot of reports and data sources that we used in this effort.
Hey, Al, can I just jump into one thing there? I think I just want to say that I think for some of these, the years don't, like, the year is the year that the report or the spreadsheet, like, it's the year that that document or report or that data was created.
That's a good point. So the year is the publication years. It's not the year that we obtained data for. Now, some of these publications had multiple years of data. Is that what you're trying to clarify, Kevin?
Yes, thank you.
Perfect. Yeah. So an example is the hydrology reports. We actually did get them every year. But other ones, like the urban water management plans, are typically released every 5 years. So obviously we don't have one for every year, but they do typically have historical data that we used. So thanks for clarifying, Kevin. Any questions before I jump into the demand analysis?
Yeah, so if you have any questions, please either type them in the chat or use a Zoom reaction, like raising your hand, to let us know that you have a question, and we will let you unmute yourself so you can talk to us. We have lots of time for questions today, so if there's any so far, please let us know.
And we will be coming back at the end too, so.
Okay, just gonna give it another 15. Okay, got a question from Paul Jenkins. City of Ventura also foster park wells. So is your question, did we get, I think it's a groundwater pumping data question. So Al, could you please go back one slide? And could we maybe just speak to the data that we have for that?
Yeah, we got data directly, I think directly from City of Ventura. Well, maybe it's a variety of sources, but we got foster park production. I think it was at a fairly high timescale, monthly, I believe, and that was used directly in the model, so we didn't have to back out any of those data. And that's an important thing to keep in mind. The large, the very large users, the municipal providers that pump, they provide data that we use directly in the model. So this analysis is not to try to back calculate their volumes. It's for the much smaller volumes by the agricultural users, the private agricultural users. So I don't know, is there a specific question? And I think there's details on these data in the data compilation report as well.
Yeah, I think it was just a miscommunication. There's a follow-up. Sorry, when you said, Paul wrote, sorry, when you were speaking of the budget, you said you used Casitas Municipal Water District for city supply, but did not mention the well field. Yeah, so we do have, I think at a minimum, we have groundwater, we have monthly groundwater pumping data for all large municipal water suppliers. And in some cases, we have daily data. And so I think we actually have daily data from the city of Ventura for some period of time. I don't recall the period, but we worked with all of the municipal water suppliers to get that information. Okay. Sorry, what?
Yeah, that's correct. Okay.
Thank you, Al. Are there any other questions? I'm looking for raised hands or more in chat. Okay, I think we can just continue on then. And if you come up with questions, you can ask them at any time or type them any time, and we'll just circle back around to them at the next question spot.
Great. So the next several slides are on the demands within the watershed. We considered the big uses of residential demands, and we used gallons per capita per day, or GBCD numbers from a few different sources. I'm going to talk a little more about those. We used population numbers from the 2010 census data, and that's a pretty straightforward calculation to come up with residential demands. We used, for agriculture, we used the VC-AC 2016 crop data. We did look at other sources of crop information, and we thought this was perhaps one of the more detailed ones, and also reasonably recent. One important note is that we did assume that these crops were fixed for the entire modeling period. We didn't change them over the 24 years. We looked at different applied water rates data, and then we did a calculation to come up with the demands within each of our regions. There's also a couple of golf courses in the watershed, Sol Park and Ojai Valley Inn, and we used ET rates for turf to estimate those demands. So the map on the right shows the VCAC data. We split it into, we've got avocado kind of shown here in blue, citrus in yellow, and then we kind of grouped up other crops in the orange. And then you can see the golf courses in green as well.
Hey, Al, can I interrupt you for a moment?
Yes.
I got a question or a comment. The slides are cut off at the bottom. Is that fixable?
I don't know.
I don't know that it's fixable right now, but Kevin, I think we will share a copy of the slides, right? We'll post a copy of the slides on the internet after presentations.
Yes, that's correct. And we did that those slides are already online for webinar 1.
Okay. Yeah, I don't know that it's fixable now. You'd have to go in and kind of re-edit the master slide.
Yeah, I don't see them cut off on my screen, but that could be another issue.
We can see most of it. It's just some of the very bottom stuff is a little bit cut off. And I recommend we move on and we'll post a version that that doesn't have that cut off at after the presentation.
Okay, sorry.
Okay.
Thank you.
Sounds good. Okay, so this is the residential demand data that we used. We found this very useful graphic in the Ventura River Watershed Management Plan that had annually varying data for CMWD in the blue line, Golden State Water Company in the green line. And I'll mention this came up 2 weeks ago. Golden State Water Company, it was taken over by Casitas in, I believe, June of 2017, which is right at the very end of our modeling period. So for this analysis, I kind of refer to it as Golden State Water Company. Now it's called, I think Casitas refers to it as the Ojai well system. But again, I'm going to use the Golden State Water Company terminology for this part of the analysis. And we also have data for the city of Ventura. which showed much lower use, partly because it's a city and partly because it's near the coast. So the nice thing is these have annually varying data, and we found that this was important for the model. If we tried to use a constant number each year for both the GPCD and for the applied water rates for agriculture, then the numbers just didn't make sense in terms of the deliveries that Casitas were making also followed these types of trends. So it was important to use data sources that were annually varying. For the Ventura River Water District, we didn't have annually varying data, but we did have a baseline number down here of 196 gallons per capita per day. And we used the kind of annual variation for Casitas just scaled down by an appropriate amount for the Ventura River Water District. So we used these 3 different GPCDs in different regions of the watershed, depending how close that region was to each of these regions. The other thing we had to do, our modeling period is 1994 through 2017, so we only got annually varying data for about 10 of those years. So we did just some pretty simple analysis to extrapolate the data both backward and forward in time. So this is for Golden State. We did a regression. We found that we tried regressions against rainfall, and that was pretty loose. So we found a reasonable regression was to plot the GPCD against the Casitas total annual deliveries, for which we had data for. For Golden State, the regression it's okay. It's R-squared about 0.5. It's not great. But we used it to extend the record, back in time and forward in time. So the plot on the right shows the GPCD that we used in the model as the blue line, and it shows the actual data points, and it also shows the regression. So we can see, we get reasonable numbers both back in time and forward in time. The Golden State Water Company is up in the OBGMA, for which we have all the measured pumping data. So we didn't really use these numbers didn't really affect our model input, but they were used to kind of check our methodology. But they weren't used directly in the model input. For Casitas residential demand, we did a similar analysis, and in this case, we had a much higher R-squared. Here's a correlation. So this is the Casitas GPCD plotted against the Casitas total annual deliveries, R-squared about 0.8. So reasonably tight correlation, and we did a similar, extrapolation both prior to and after the period for which we have data to complete our entire modeling period. One thing that we did was in the drought years, so 2014, 15, 16, and 17, we didn't use the regression directly because the region was in a drought then. The Lake Casitas was getting much lower. There are a lot of drought conservation measures going on in the watershed. And so we used some guidance from Miners Oak's kind of drought stages, and we just did a fairly simple 20% reduction from a baseline value in 2014 and 15, and then a 30% reduction in 2016 and 17. And this was kind of based on the lake levels within Lake Casitas that were continuing to decrease during this time. So the model that the data that we used in the model is this blue line. And this map just shows the different regions, which I'm going to talk more about later, and the different water service providers and which GPCD numbers we used. There's a lot to go through in the table, but trying to keep it relatively simple. Ventura River Water District is this pink shape here. So we used obviously the VRWD numbers for them, and we also use those within Region 2 and Region 1. And those numbers are lower, which is a reflection both of perhaps lower temperatures, but probably more so the types of residences in there. Typically, the lots or the property sizes are smaller within this region compared to up in Ojai. We've got larger lots with, some with grass and swimming pools as well. In the most of the rest of the watershed, we used the Casitas numbers, but obviously for Golden State, we used their numbers directly. So kind of doing the math, taking the GPCDs and multiplying by the population data, we can kind of come up with estimates by region. The pie chart here kind of summarizes things. We can see that region 1, now again, this excludes the city of Ventura, but region 1 has a relatively small piece of the pie, whereas regions 2, 3, and 4 comprise most of the residential demands. And that reflects the population centers of, I think, Miners Oaks and Ojai up in these regions. And again, region 5, the upper Ojai Basin has a pretty small piece of the residential demand. Switching now to the agriculture as well as the golf courses. Again, we use the VCAC 2016 crop data. The map is shown on the right. We went over that earlier. And we looked at a variety of different applied water rates. This table summarizes things here. And these are the rates in acre-feet per acre per year. So the OBGMA on their semi-annual reports, they use a value corresponding to 3.4 acre-feet per acre for citrus and avocado, and 4.0 for other crops. The UVRGA in their 2020 technical memorandum used values of 2.0 acre-feet per acre for both citrus and avocado. The Department of Water Resources publish annual data, so they publish a data set where the numbers vary from year to year, and it's based on consideration of climatic conditions in the year that's passed, and also soil conditions. And their average numbers were for citrus and avocado were 3.4 feet per year, and that's in pretty good agreement with the OBGMA numbers. And for other crops, it was lower, like 1.9 acre-feet per acre per year. And I've put some footnotes in here. It's interesting to note that the range, so it's 3.4 as an average value, but the range for citrus and avocado was 2.4 feet per year, all the way up to 5.3 feet per year in 2014. And 2014 was a drought year. I'm going to talk more about later why we didn't use that number directly. We thought it was a kind of unrealistically high number. In 2014, that the water, it was in a drought. There wasn't enough water to go around, and we'd made some kind of drought correction factors. The other sources I like to look at are the SGD. So that's a report by Stahl, Gardner, and Dunn in 1992. And they again did some analysis that looked at about a 20-year period from the 70s through to the 90s. Their average values were 2.9 acre-feet per acre for citrus and avocado, 2.0 for other crops. But again, they looked at a 20-year period, and their range was 2.5 feet per year to 3.6 feet per year. And this report also provided some earlier studies, the Murray et al., which is also known as the MBK report, DWR numbers, and some older state water board numbers, and kind of concluded that these older numbers were probably too low for this watershed. We also looked across at the Fox Canyon GMA, which is located to the southeast, and again they have a range of numbers depending on the amount of ground shading with the orchards, as well as the different year types, and also for different zones. But based on this, we went forth with the DWR numbers, and we think they're reasonable numbers. And a big advantage of those is they have a number that varies annually, and that was important for the balance. So a little bit more on these DWR numbers. We've plotted them here as a function for the different years from 1998 through 2015. The irrigations in acre-feet per acre for citrus and avocado up the top, and for the other crops down the bottom. We put here in orange bars the average values. We can see there's some variation about the average. And again, these numbers are based on demands that include weather conditions, and not on actual what was delivered to the crops necessarily. So one important thing is that these interannual trends indicated in these demands were also reflected in the supply data, and particularly in the deliveries from Casitas. So that was a big factor in using them for the crops. For the golf courses, we used a simple rate of 4 feet per year, or 4 acre-feet per acre, and that was in agreement with the OBGMA semi-annual reporting forms. So again, our modeling period is 1994 through 2017. So there's a few years on either end we don't have these data for. So we did a similar type of correlation to try to extrapolate. In this case, we found the best correlation was obtained by plotting the applied water rate as a function of OHI annual rainfall. And we can see for avocado and citrus is a bit of a weak correlation, but as we get more rain, they need less irrigation, which makes sense. For the other crops, the correlation was pretty weak. We ended up not using this correlation, but we did use the correlation developed for avocado and citrus, as I'll show on the next plot. So this plot shows what we used in the model, for citrus and avocado, the blue line, and the gray symbols are the actual data points. So we extended about 4 years prior to the data and 2 years after the data. And we see we get some kind of numbers within reasonable range. So we use the correlation for the citrus and avocado, but for the other crops, we just used the annual average value. We didn't feel the correlation was strong enough to consider using. So that's how we came up with our applied water rates for different crop types over the entire modeling period. And then we multiply those by the different acreages, and we can get our kind of average annual ag demands, which is shown here in the pie chart. And again, starting down in region 1, it's a fairly small piece of the pie. Regions 2 and 3 have larger pieces of the pie, but by far the largest region is the region 4 up in here. And I'll point out that region 4 is really the OBGMA. So in region 4, we actually have estimates for these data. So this analysis is not used directly for region 4. We use region 4 to kind of confirm our approach. So, but it's important to note that we're really only using the analysis in regions 1, 2, 3, and 5. Region 5, the Upper Ohio Basin, is also a smaller piece of the pie in terms of agricultural demands. We can also compare, the kind of watershed.
Al, sorry, can I jump in for a sec?
Yes.
I think we're getting a few comments that we're having your mic cut in and out still. So I think this is something that during the break, I might work with Al to try and fix this. I think until the break, if you need us to repeat something, just please let us know. And I'm really sorry that we're having this trouble again. Does that work, Al?
Yeah, we can try and sort it out. I could try my phone, or is it better than 2 weeks ago? I don't want to switch back to the old one.
I don't know. I don't know that that's necessary. So I think you could try turning off your video. That might help. And I was also going to suggest, and then we also got a technical question. Can we go back one slide? So yeah, just thanks folks for your patience. And if there's something that cuts out and you want us to repeat it, or obviously you wouldn't know what it was, but if you need us to repeat something, just please let us know, and we'll go back. We have a lot of time today, so.
I've stopped the video, so let's see how that works. Thank you. So do you want to go back one slide?
Yeah, we got a question. Could you go back one slide, please?
This one or one more?
Okay, so Brian, if this is a question from Brian Bondi. If this is a repeat, do you want us to repeat a slide? Could you maybe is it this?
Let's unmute Brian.
Oh yeah, that's a good idea.
I can do it. I have it here.
Good morning. I'm just trying to match up the map with the pie chart, and
Okay.
some of the color, yeah, it's just the colors on the map
Yeah.
correspond. So I'm trying, I want to confirm whether there's an error or both correct, they're just different.
No, they're just different. But if you start at region 1 at the orange segment and go clockwise, region 2, 3, 4, 5. Yeah, matching the colors would have been helpful.
So
for sure.
So region 2 and region 1 span the upper Ventura River Basin, and they're orange pie slice and red pie slice.
Region 1 is the orange pie slice, and it covers the lower basin plus part of the upper basin. And this, I'm going to get to why these are defined later, but it's related to the Casitas pressure zones. And then at the very end of the presentation, we actually take another look at the numbers by groundwater basin as opposed to these regions. So I know there could be some disconnect. I believe the groundwater basin boundary is, more down here.
Okay, I'll wait for that. Thank you.
Can you see my cursor?
Sure. Yeah, I'll wait.
So yeah, region 1 includes both the lower and upper groundwater basins, both lower Ventura and upper Ventura groundwater basins. Regions 2 and 3 are in the upper Ventura basins. Does that make sense? Okay. Any improvement on the mic? We'll give it a little more time.
It's been consistent so far.
Okay.
So, and there's another question about region boundaries. So it sounds like we'll just get to that when. I think you said that you'll get to that soon, so we'll do that then.
Another thing we can look at is kind of the watershed average demands, agricultural versus residential, and this analysis shows, about 1/3 is residential and 2/3 agricultural. There are some smaller industrial uses in the watershed, but in terms of trying to back out these unknown pumping rates, that they weren't important in the analysis. I do have a pause for questions before we get on to the supply portion. Are there any more, or should we just keep going?
I do have a question from the chat. It is, how were the region boundaries drawn? So is that something that you're getting to in the next?
Yeah, it's related to Casitas pressure zones. I think the next section we'll explain that.
Okay, so we'll come back to
that. There were reasons for the boundaries.
Yeah. Thank you. And the mic is still cutting in and out.
It might be worth pausing and having Al try to call in and using his phone audio.
Should we take a 5-minute break then?
Yeah, let's do that, because we do have time, so let's try and fix it.
Okay. So thank you, everyone. We'll take a break and we'll work on this. I think Al and Dan and I think I can throw us into a breakout room and we can talk about it there.
Okay, so we'll come back at maybe 10 o'clock, Kevin?
Yes, we'll come back at 10 o'clock and we're going to work on this microphone.
Okay. All right. And Al, maybe you could stop sharing for a minute.
Sorry about that. Thank you all. We're going to try a solution. And thanks for bearing with us. And if it doesn't work, we'll try something else. We have a longer break in about 15 minutes. And we still have one tabled question about region boundaries, which I think we're about to get to. Al, are you ready to continue?
Yes, I'm here. Can everyone hear me?
Yes.
Great. Wasn't sure if I had to be unmuted. Great. Hopefully this works better. So yeah, I think the next little section will answer the questions on those boundaries, the regions, the 5 regions that we used. There'll be how we came up with those. Are there any other questions on this before we move on to the supply side?
No. Oh yeah, sorry. Any other questions? And I just wanted to share, I think we did resume the recording of the meeting. Okay, we got a question. Could you please explain why a population growth was not assumed?
Yeah, we did consider this, but I think part of the modeling strategy was just, we didn't want to have, having fixed land use, and a lot of things are fixed in the modeling period. If we want to use scenarios to look at population growth, we want to look out into the future, that's something that can be done. But in terms of, looking at the 20-year period that we're considering, the population growth wasn't huge. It was kind of within the margin of error of our analysis.
Okay, thanks. And Ali, if you would like me to give you permission to unmute, I'm happy to do that. Okay. Are there any other questions? Got a lot of time today. Happy to take questions. Okay, let's keep going then.
Great. So the next section talks about the supplies of water, and a lot of the focus is on the distribution of Casitas water within the watershed, and that's going to get to talk about the pressure zones and how we came up with those 5 different regions. So for the Casitas deliveries, we found data. We have data for the total annual deliveries that they deliver, mostly from the lake, also including the Miramonte well. And again, this was before Casitas took over the Ojai well field, so that's not really in this analysis here. So we have their total annual deliveries for all modeling years. We got those from a few different sources: consumption reports, urban water management plans. And that's shown here on the right in the orange line. And we can see there's quite a lot of variation from year to year, largely driven by, wet years versus dry years, and also the drought. In addition to that, we found data for imports to Golden State Water Company service area. That's shown here in the brown line at the bottom of the graph, and also imports into Region 4, which we chose to kind of match the OB-GMA boundary. So we used those data directly, but kind of throughout the rest of the watershed, we had to figure out where the rest of these total deliveries were delivered to. So that's the key to backing out the local groundwater pumping. So again, I showed this map earlier just to show the complexity of it. They deliver from the lake to the gravity zone, and Region 1 was chose to be the gravity zone, and therefore the boundary is up here near Oak View, I believe. And then there are other pressure zones that we use to define our regions, and it's probably better shown on this kind of schematic that Casitas provided us. So Zone 1 is what we used for our Region 1. So these are pressure zones defined by Casitas, and then we defined our own regions based on them. Our Region 2 was a combination of Casitas zones 2 and 3. We found it hard to disaggregate these zones because there's kind of a lot of overlapping, so we combined them. Region 3 is up in this area, so that's Casitas Pressure Zone 4. Then Region 4 we used the OB-GMA, which primarily corresponds to pressure zones 5 and 8, as well as deliveries to what Casitas now call the Ojai well system, but what I'm still calling Golden State. And then Region 5 was the upper Ojai Basin shown here. And there's also a pressure zone here that is outside of the watershed deliveries along to the coastal communities and agriculture. So Casitas were able to provide us with volume deliveries to each of these book numbers or zones from mid-2015 through partway through 2020. And so the first thing we did is plot up the volumes of the deliveries from year to year. We did that on this upper chart up here. So we've got water year 2015. It's a partial year, so the total volume is less. And then we have complete records for water years 2016, 17, 18, and 19. And then again, a partial year for water year 2020. And these are colored by the 9 different pressure zones kind of shown in this map out here to the left. So this plot was useful, but what was more useful is kind of expanding, plotting the fractions rather than the total volumes. So we did this in the lower chart here. And we can see that the fractions from year to year are relatively consistent. So it kind of tells us that it's a reasonable assumption to make that Casitas are delivering the same fractions of their distributed, their total deliveries go to the same zones in prior years. So based on these pressure zones, I probably talked about this already, but we defined these 5 different regions that we've had questions about. And so region 1 corresponds to pressure zone 1, which is the gravity fed piece. Region 2 corresponds to Casitas zones 2 and 3, and that's shown here. Region 3 corresponds to pressure zone 4. And we note that miners oats can actually take water from either region 2 or region 3. Okay, they can take it from different pressure zones. Region 4 is pressure zones is 2 things. It's kind of chosen to encompass the OBGMA to a large extent, but it's also corresponding to pressure zones 5, 6, and 8. And then there's another pressure zone for Golden State Water Company. And then region 5 is pressure zone 7, shown up here. And then we have the region outside that's not shown on the map that we did need to include in our water budgets. We wanted to make sure that the deliveries from Casitas to outside the watershed were obviously subtracted from our analysis. So I mentioned before that the city of Ventura is pretty complex because it's both in and out of the watershed. It's also both in and out of the Casitas service area, and they have supplies from groundwater pumping out in the Oxnard Plain and other areas. So we didn't want to go into a full budget for Casitas, so for the city of Ventura, but it was important to understand how much of the region 1 Casitas water they used. So we did a separate little analysis for the city of Ventura, which is kind of summarized in this table. So this is our 24-year modeling period. I'm not going to go into a lot of details here, but we come up with estimates for their Casitas delivery based on data and other information and reports. We had a question earlier about the municipal wells. These are actually the volumes for combined for Foster Park and the Nye wells that the city of Ventura uses. So we have data for those as well. And then what we found we had to do is actually subtract out these Casitas delivery volumes from the total Casitas supplies before we then split it the remaining water amongst the other regions. And this is because these volumes are quite large and a little bit variable, and to make sense of the numbers, we found it easier to subtract out the deliveries to the city of Ventura and then divide up the remaining water between the remaining regions. So we did this, and then based on the volume data that we have, this is how we split the water between the different regions. And again, I apologize for the lack of color coordination, but region 1 here is the orange. That color actually does match. And based on analysis, they take about 9% of the Casitas deliveries after subtracting out the city of Ventura's amount. So these fractions exclude the city of Ventura. Region 2 take more like 20%, Region 3, 17%, Region 4, which is the Ojai region, about 26%, and then Region 5 up in the upper Ojai Basin, about 4%. And roughly a quarter of the water is delivered along the coast. So we can use these fractions and apply them to the time series of data we have for total Casitas deliveries to estimate the volumes of water in each year that go to each of these 5 regions. And so we did that. It's just take our time series charts and split it up. We also had to account for the additional data that we had up in Region 4. We had estimates for what they call imports from Casitas in Region 4, which is shown here in this brown line. And we had also had information on Casitas imports into Golden State Water Company. So we also subtracted out those amounts or made adjustments so that those data, our splits matched those data. So this is, this really gives us defines the volumes of water in each year within each of these regions. And then the next question is, what do we do within those regions? And this is where it starts to get a little more intricate. Within each of those regions, we have the volume of Casitas water in any given year. So we know how much that is. So within those regions, we generally assume that the Casitas water first went to meet unmet residential demands. So there's other providers within these regions that meet residential demands. For example, Ventura River Water District and Miners Oaks, they meet residential demands, but in some years, our calculations showed those demands weren't completely met, and there were other residential demands that we assumed were made up primarily of Casitas deliveries. And then after we delivered the known Casitas volume to the residential demands, we then said, okay, the leftover is going to go to agriculture. And then the question was, where within that still relatively large region are we going to put that, to deliver that water to agriculture? And this is where we broke these larger regions down into these smaller sub-regions shown by these yellow polygons. And these sub-regions were determined based on grouping crop data. So if you look closely, you can see the crops are shown here in this kind of peach color. So we grouped crop data and also agricultural wells, and active agricultural wells shown here by the dots. We grouped them into these sub-regions. And then the leftover water after meeting the residential demands, we then sent to the different sub-regions. Sometimes the information in some sub-regions, for example, doesn't have agricultural wells, so we prioritize water going to them first, and I'll talk more about that as we go through each region. And then from that, we're able to look at, okay, unmet agricultural demands, and then we assume those to be made up by the agricultural, by groundwater pumping. I apologize for the background noise. I'm in downtown LA and there's always things happening here. So this is kind of the overall approach. We got pretty intricate in terms of trying to define our spatial variability of the agricultural pumping. There's a few other pieces of information that we brought in. For example, the UVRGA did a survey in 2017. I think the report was published in 2020. That yes, it gave information that specific wells had certain acreages of crops that were irrigated by those wells, and we honored those. So we made some adjustments to honor those, that extra information that we had. We also made some adjustments in the drought years. We artificially reduced demand. I kind of alluded to that earlier, and I'll talk more about it as we go through the examples. And then in some wet years, we adjusted some of the pressure zone splits between regions 2 and 3 to make sense of the numbers. And they were fairly small adjustments in the grand scheme of things. So this is kind of the basis of our approach, the overview of our approach. And in the next, I think after our break, I'm kind of going to go through region by region, and hopefully this will crystallize into something fairly clear. I think it's a good time to pause for questions before we have our scheduled break.
Okay. So please ask questions. You can raise your hand and we can give you permission to unmute, or you can type a question in chat.
How's the audio?
It's been much better. It's good.
Okay.
It's been consistent for me as well. I got a question or comment from Dana Engel. Miners Oaks Water District could provide actual purchase volumes from Casitas Municipal Water District. Did that type of data get used to ground truth the estimation techniques? So we did get water purchased information from another part of the State Water Board called the Division of Drinking Water, where large and small municipal water suppliers report their report a variety of information to the State Water Board. Al, was that information? Could you speak to how that was used?
Yeah, the Department of Drinking Water DDW data was used, I believe, 2014 onwards. I believe that was when that record started. So we did check it against those. But and that data is helpful, but I think bigger picture, it's the whole region that is really, balance in the regions is key.
So yeah, Dana, we're always interested in new information, and we'll kind of consider whatever is provided, and if it's something we can incorporate into the model at this stage, we'll look at that. I'm not going to make any promises, but if it's something that can be provided, then certainly please send it to us. So thank you for that comment. Anything else? We're about to hit a 15-minute break, so maybe people need some coffee, stretch, but
Kevin, could you just take a minute to review the schedule, like the break, and then what we're going to do after the break, and then?
Yeah.
Okay.
So we're going to take a break, and since we didn't get very many questions, if people come back and after they take a break, and if they come back with questions, maybe we can take a couple more before continuing. So we'll take a 15-minute break, and then we'll come back, and Tech is going to present more on results. They got some tables and plots, and then a summary, and then we'll wrap that up. That's about 45 minutes, and there will be some time for questions during that next set of the presentation, and then we'll also, our goal is to hit our longer discussion section around 11:15, 11:20. So we'll have a long 40-minute odd or so time for discussion afterward. So let's take that break, come back in 15 minutes. I got a question. Could you please show slide 21 again? So Al, maybe if you could leave slide 21 up, please.
Sure.
Sorry, you're about to.
I was going to put back at what we shooting for 10:35, but let me.
Yeah, it's 10:35, and so like I said, about another 45 minutes of presentation with pauses for questions, and then we'll have the whole remainder until noon for discussion and wrap up.
Okay. So back at 10:35, Kevin, I'll put that in the chat.
Okay. Yeah, and if you have questions that you come up with in the next 15 minutes, please throw them in chat or raise your hand, and we'll get to them when we come back. Hi, folks. It is 10:35. Welcome back from the break. I have resumed the recording.
Great. Should I pick it up, Kevin?
Yeah, let's, we've got two questions in chat that I wanted to address, and I don't see any raised hands, so we'll just look at these two questions then. Okay, so the first question is from Diana Engel. Kevin, will the release of the model include technical written documentation on all this methodology? And I think the answer is yes. Is that correct, Al?
Yeah, that is correct.
So yes, and just to kind of, oh, sorry, go ahead.
And more information than we can provide on the webinar for sure, but I think this is valuable to bring people up to speed and give a big picture view of the approach.
Yeah, and just to kind of repeat what we said earlier, this is not the only opportunity to provide technical comments on this modeling approach. This is, we want to get this information on water demand and distribution, and later with calibration and validation, and with the previous webinar with additional changes to geology. We want to get all this information out early so that folks can be thinking about it, can be aware of it, can potentially flag major or minor issues and provide those comments as early as possible. We will be releasing, we will be releasing the draft GS flow model with full draft documentation. And so that will be a longer, that will be another review period, TAC and comment period that will be 60 days long. And I'll talk more about that in webinar 3. I hope that answers your question, Diana. Please let me know. And we have a second question from Larry Yee. How do your overall supply and demand figures compare with the results of the Casitas Municipal Water District's Comprehensive Water Resources Plan report? Al, is that something you can speak to?
I'd have to check on that. We do have some kind of checks at the back end that checks it to some Casitas data. I don't know if it came from that report specifically, but they do compare well with some other data that we've got from Casitas.
Okay. Looks like something we'll need to think about a little more, or maybe just check back on internally. So thank you for that question, Larry. Are there any other questions before we continue with the presentation? For raised hands or questions in chat, got a thank you from Diana. You're welcome. Give just folks another couple seconds here. Okay. Well, thank you for these questions. Please keep them coming. We do have a lot of time today, and we want to answer your questions and hear your comments. That's why we're doing this. All right. It's all you, Al.
Great. Thank you, Kevin. I'm going to try turning on my video. If the audio, it should be fine because the audio is a separate line, but if it does cause issues, I'll turn it back off. I brought the outline slide in just to kind of show again where we are on the talk. Went through the demands and the supplies and kind of the overall approach. Now the next piece is kind of looking at the different regions that we defined and the results, starting with region 4 first, because I've mentioned this several times, that's essentially the OBGMA. So this provides a check on our methodology because, essentially everything is measured up in there. And then I'm going to go through region 5 to just kind of show an example for a region that we don't have everything measured and how we use that to back out the unknown agricultural pumpings, and then kind of go quickly through the remaining regions. There's a lot of tables and numbers. I don't want to dwell on them. I will spend some time kind of looking at the plots and conclusions from the plots. And then at the end, just kind of summarize the results of the study in terms of pumping volumes, and also some kind of checks with other data sources out there. Okay. Oops. Okay, so just to back it up a little bit, we essentially did these annual budgets by the service areas within each of these 5 larger regions. So region 4 is essentially the OB-GMA. The boundary is in here. We have a little bit of the Senior Canyon region extends outside the boundary, and also a little piece of the Golden State also extends outside the boundary. But for the most part, we know a lot about the supplies and demands, all the supplies of the water in this region. Then I'm going to go over to region 5, which includes, Casitas Municipal Water Company out on the watershed boundary, as well as the remainder of the region where they have a lot of agriculture. Region 3, which includes Miners Oaks, as well as these areas up here. Region 2, which includes the Ventura River Water District, Rancho de Cio out to the east, Rancho Matilaha out to the west. There's also a couple of smaller ones, Tico, which is, I think, maybe in here, and Old Creek, which is a tiny one somewhere. We do balances for each of those. And then finally, region 1, where again, we take the water, the city of Ventura out of it and do an independent imbalance on the remainder. And it also includes a Casitas Municipal Water Company within region 1. I also did a separate balance up on North Fork Springs, which is up in Matilaha Creek, which was pretty straightforward. I'm not going to go into details on that. So first, region 4. This is kind of a close-up from the map that I showed previously. We've got Golden State area, and this shape out to the west. A small piece of it is outside the OB-GMA boundary, which is shown here in the pink dashed line, as is some of the Senior Canyon service area and some of the Hermitage service area as well. And we broke down the remainder of the region into these subzones. It's hard to see the text in here, but we've got 4A, 4B, and 4C, which kind of group crops with specific wells. So we go through and we use our different data sources, and this again is just to assess the methodology. So this is for the Golden State Water Company service area. We found, have data for deliveries from Casitas. We have measurements for the domestic wells within that area because it's for the most part within the OB-GMA boundary. We have measurements for the municipal groundwater pumping, which was mostly Golden State at that time, since been taken over by CMWD. We've got estimates or reports for volumes for ag groundwater within for the portion of the service area within the OB-GMA. For the smaller portion out to the west, we didn't have estimates, but we kind of compared crop areas and they were pretty similar, so we just assumed the same volumes for those wells out there. If we do this, we can sum up our total supplies, which is in this column. And then on the demand side, we've got our residential demand, where we use, just to refresh your memory, the GPCD numbers from Golden State, and multiplied it by the population. And then we've got the ag demand. We use the VCAC data and the applied water rates to get our ag demand. If we sum up those two demands, we get our total demands, and then we can compare them. And obviously it's not in perfect balance, but it's in pretty good balance. And we can do this for other regions. So this is a Golden State. We can do it for other service areas within region 4. So this is a similar thing for Hermitage, where they don't have, the differences are they don't have domestic groundwater, they don't have municipal pumping. And for that one, we had to estimate based on the remainder of the Casitas water, how much Casitas water they might get. And we estimated that based on relative demands. And we've obviously got, pretty small residential demands in the Hermitage service area, larger agricultural demands. So we can stare at these numbers all day. Soon I'll get to some plots, which I think summarize things in a more digestible way. Did a similar analysis for Senior Canyon service area. A couple of unique things for that service area is that they have local surface water diversions. So they have diversions out of the West Fork and North Fork, as well as the tunnel, which is high up on the mountain. We spent a bit of time talking to Senior Canyon Water Mutual Company to try to understand those volumes. And we actually got data from, I think, year 2000 onwards, which we used here. Prior to that, we did some correlations based on kind of year types, where it's a wet year or a dry year, to kind of backfill those earlier years. There's also surface water diversion into the Topo Ranch. We had some data in the later years, and we assumed some, an average value in the early years. We didn't have enough data to develop a decent correlation for that. But these numbers are relatively small compared to other data sources. So again, we do our total supplies and total demands, and we'll do some comparisons, which you'll see in plots shortly. And then we look at the remainder of Region 4. So this is primarily the kind of leftover pieces where there's a lot of agriculture, and we do similar types of analysis. We also need to understand for water that's going to ag, how much of it comes from groundwater versus how much comes from Casitas. It's not important for Region 4 because Region 4, everything's measured or already estimated directly. But we need to develop an approach to use in other regions. So typically I've mentioned this before, we assume the Casitas water first meets the demands of residential demands, and then any leftover is distributed to the ag, and then the any ag demands that are not met is assumed to be met by groundwater pumping. It's not that important in Region 4, but for other regions it is important. So we've got spreadsheets like this to kind of look at these different sources of water that go to ag to enable the pumping to be broken out correctly. Again, those tables and numbers are tough to look at. I think these plots really summarize things in a way that's easier to understand. So the upper left plot is for Golden State Water Company's service area. We're plotting as a function of time the residential demands in blue, agricultural demands in green. So within that service area, most of the demand is residential, but agricultural is also an important piece of it. We add those two together to get total demands, which is in red. And then in the case of Region 4, we add up our total supplies and get the orange line. And we see that, it's a pretty good match in general for Golden State. We do similar in the Hermitage service area. There we've got very low residential demand. It is dominated by agriculture. So you can see under the red line is a kind of dashed green line, which is agricultural demand. We sum up the total supplies, and generally it's in pretty good agreement. I guess generally we're a little lower perhaps. I'll talk more about that shortly. And then noted in all of these areas where ag is dominant, we notice that the demands in the drought years, 2013 and 14 in particular, are far from being met. And that is because, if you recall back to using the DWI applied water information, in 2014 it had a very, very high applied water rate of 5 acre-feet per acre for avocado and citrus. And that is based on the assessment of the weather conditions. Those years were extremely dry, but realistically, in those years, I don't think the demands were able to be met. And this kind of shows that, there isn't enough water to meet those demands in those drought years. So the Hermitage service area, as well as the rest of Region 4, is dominated by ag, so their trends kind of look similar. The actual numbers are different. These numbers over here are much higher than up in Hermitage. Senior Canyon is also dominated by agriculture, but there is also a pretty substantial residential component as well. But these trends look similar. We can look and do our pie chart analysis of the region. So this is for annual average demands. On the left shows the breakdown between residential and agricultural, and then the average annual supplies show the different kind of supplies that go to meet those demands. And I'll spend a little bit of time talking through this. I like to look at it a couple of different ways. If you combine the purple and the orange, that's your supplies from Casitas, purple being supplies to residences, orange being supplies to ag, and that makes up almost half of the pie up in Region 4. If you combine the purple and the green, that's your residential supplies. Most of that is supplied by Groundwater, which was Golden State Water Company primarily, and now the Ojai Well System, and a little piece is supplied by Casitas. And then if you look at the blue, the red, and the orange, that is the ag demand. And we can see, a little bit of that is supplied by the surface water, primarily in Senior Canyon and Topa Topa. But the bulk comes from either Casitas or Groundwater pumping. So that's kind of some interesting results that we can conclude from this analysis. A couple of takeaways from Region 4, which we want to keep in mind as we move on to the other regions. Again, Region 4, we have estimates of the pumping volumes. So we're kind of using this to verify our method and also learn a few things. On average, the supply was 11% less than demand, and that's in the non-drought years. We thought this was pretty reasonable within the range of anticipated margin of error. As an example here, for groundwater pumping, if you've got large municipalities that are measuring it, the estimates may be within 5%, but if you're kind of relying on self-reported estimates, the OBGMA says, plus or minus 10% is probably reasonable. And that's not the only source of uncertainty. There's issue, could be differences in crop areas or the applied water rates. But I think in general, this 11% difference is pretty reasonable and kind of validates our approach. The other important takeaway, which I mentioned, is that the high ag demands during the drought, so water years 2013 through 17, were not met. The data showed that they were not met. And we feel this is important to carry this conclusion through into the other regions. We don't want to assume that in the drought years, they're able to pump enough to meet all those demands. That just doesn't seem realistic. So the way we dealt with that is we adjusted the ag demand targets in other regions during the drought. And I'll talk more about that actually right here. So we used a similar approach to the residential adjustment, which was based on kind of different drought stages. So just to summarize what we did here, we assumed a 20% reduction in water years 2013 through 2015, and a 30% reduction in water years 2016 through 2017. And then in addition, in water year 2014, that's where we had DWR applied water rates of about 5 acre-feet per acre. We didn't think that was realistic, so we put a 20% reduction, an additional 20% reduction on water year 2014. And the table on the right kind of compares the adjustment factor that we use in regions 1, 2, 3, and 5 with the factor that was essentially calculated from all the data in region 4. And they match up pretty well. So I think this approach is reasonable to carry through into the other parts of the watershed. So moving through is just an example into Region 5, which is the upper Ojai Basin. Again, it has the Casitas Municipal Water Company kind of straddling the watershed boundary, and then it has quite a lot of agriculture and ag wells. We broke that region up into 4 different sub-regions and went through and did our supply and demand analysis, and I'll go through each of those right now. So for the Casitas, we used our pressure zone splits to estimate the Casitas deliveries to the region. There's also some domestic wells. We assumed 0.5 gallon per minute for each of those domestic wells. So that's some of our supply. The private ag water, this is what we're trying to estimate. We don't have that, so that's what we back calculated. So to do that, we needed to look at the demand side. So the residential demand, again, we used our GPCD numbers and population estimates to come up with the residential demand in this column. And the ag demand, we used the VCAC data and the applied water rates with the drought adjustments to come up with the ag demands in this column. We add those 2 demands together and we get our total demand. We then match our supply to our demand to back out the pumped ag, the agricultural pumping. And we assume there was enough pumping to meet demand, except in these drought years where we, by design, reduced our agricultural targets to kind of match what we've seen in Region 4. These are the plots I have. So these are the tables. I have plots coming up soon, which I think will help understand things. This is the same approach for Casitas Municipal Water Company service area. I'm not going to go through in detail. Note the numbers are much lower in general, so generally less important. Again, we had to split up or determine how much of the ag demands were met through Casitas water versus pumping, because we're really trying to get at the pumping, but we also know that some of the demands are met through Casitas water. So we first applied the Casitas water to the residential demands that weren't met, and then any leftover waters we split between the 4 different sub-regions. Typically, we split based on the relative crop demands within each region. And some of the other areas, we made some other adjustments, which I'll talk about shortly. And then the remaining of the demands to meet the agricultural targets, we assumed were made up of from groundwater pumping. So in terms of developing input into the model, this is the kind of the level of detail we got down to. We got estimates, the total groundwater pumping volumes in each of these 4 sub-regions for Region 5. And then each of those sub-regions had a certain number of wells, and we basically split these pumping volumes among those wells. To summarize in the chart, similar to what we showed before, here's the overall Region 5, mostly ag dominated, but there is some residential demand as well. We can see that in the early years, we meet the demands, and in the drought years, we do not meet the demands, and similar trends to what we saw in Region 4. Similar plots for Casitas, kind of similar trends. Casitas is residential dominated, and also note that the numbers in Casitas are a lot smaller, 100 or a couple hundred acre feet compared to a couple of thousand acre feet per year. Kind of summarize things, an annual average, we go back to our pie charts. The Region 5 is dominated by agricultural demand for the most part, shown here on the left. And we can look at our different supplies on the right. So we can see, look at similar things. Up in Region 5, there are no surface water diversions, that's the 0. We can see how much residential is met, supply is met by groundwater, and that's primarily through Casitas Municipal Water Company, as well as some domestic wells. We can see how much of the residential is met through Casitas, and how much of the ag is met through Casitas versus the pumping volumes here. Now going more quickly through the other regions, there's some kind of unique features I want to point out in some of the regions. So this is region 1. Again, we subtract out the city of Ventura and just do an analysis based on the remainder of region 1. We have our different sub-regions, and what I want to point out is sub-region 1B here. There's quite a lot of ag crops, so agricultural demand, and there are no active ag wells within that region. So in this case, when we split the leftover Casitas water, so after satisfying the residential demands with the Casitas water, we then prioritized the rest of the delivery of the Casitas water to region 1B, because we know that they aren't able to make up any deficit by pumping. So we first wanted to meet regions 1B demand before we split it to regions 1C, 1A, and 1D. So we did that. I'm just going to skip straight through to the plots to show you what we've got. So region 1 as a whole is, I guess about a third or a quarter is residential demand, the rest being ag demand. We see the total demand here in red, the total supplies are in orange. We get the same kind of typical deficits, if you will, in the drought years. And there's also a couple of deficits in these earlier years. And that's due to, for example, in 1998, there wasn't a lot of Casitas deliveries in general, and there appeared to not be enough Casitas deliveries to meet the demands within that region where they didn't have groundwater pumping. So we don't fully meet the demands in those regions. This is for Casitas Municipal Water Company, which is a very small mutual water company. In there, that's, I think, 100% residential demand, and we assume those demands are met. Again, for residential, we did do the drought adjustment in the demand curve. That's why it looks like the demands are met, but you notice that the demands are much lower. If we kind of look at things on an annual average basis, we see that ag is about 3/4 of the demand within this region versus residents. And again, this does not include the city of Ventura, which would obviously change this makeup. We can look at the different supplies. So Casitas supplies a good chunk of the residential demand as well as a good chunk of the agricultural demand, and then this groundwater pumping to kind of make up the rest of the agricultural demand. Going on to region 2, similar to region 1, it's a little more complex. There's a few more water districts in there that we broke down. And one of them, Rancho Deseo here, has no ag wells, so we did a similar prioritization of Casitas deliveries to this region, to Rancho Deseo. I'm just going to jump straight in. Then we had to do some adjustments between regions 2 and region 3. We found that in some years, particularly dry years, we had to change our Casitas splits a little bit to make the numbers make sense. So we did that. Specifically in the drought years, we moved a little bit of the water from region 2 to region 3, and we're talking about a couple hundred acre feet, so not large amounts. It's like less than 2% of the total delivery, so it's relatively small changes. And then in the wet years, we had to do the reverse. Actually, had to remove a little bit of water from region 3 to region 2. So in 1998 and in 2005, we adjusted the splits a little bit. And these adjustments are kind of within the kind of the variability that we'd seen in the pressure zone data that Casitas had provided us. So going through to the results, we've got on the upper left, Ventura River Water District service area, dominated by residential demand. Total demand is in red, and the total supply is in orange. So for the most part, we are meeting demand. We didn't quite meet demands in the earlier years, and that's possibly due to not having, maybe that could be related to our Casitas splits, but we're pretty close for the most part. Rancho Matilaha, there we assumed that there's groundwater pumping, so they're able to pump to meet the demands in the early years, but then during the drought period, they are not able to meet their full demands. And again, that is dominated by agricultural. Rancho de Cio is also dominated by agricultural, but they do not have groundwater pumping. Again, we prioritize deliveries of Casitas water to them, but again, the deliveries in 98 were on the low side, so we weren't able to meet the demands. But we're talking about maybe 80 or 90 acre feet of difference, and not a huge volume in the grand scheme of our model. And then overall for the kind of remainder of Region 2, it's kind of equally, the demands are equally split between residential and agriculture. And we can see we meet the demands in the early years, but do not meet the demands in the drought years. So we've kind of brought in the patterns that we saw in Region 4 into each of these other regions. A couple of little smaller mutual companies within Region 2. I'm not going to spend a lot of time, just note that the volumes just are very low, but we did include them in the analysis as well. Looking at the overall region, the demands, it's roughly 50-50 agricultural and residential. And in supplies, there's no surface water diversions, but the supplies are pretty equally split between, Casitas, groundwater, and also deliveries to residential versus ag. So interesting conclusions there. Going to Region 3, did a similar approach. Again, we had the small exchanges of water, Casitas water between Regions 2 and 3 that were also obviously impacted Region 3. An interesting note here are the surface water diversions that come out of the mountains. I forget the creek up there, but they feed some agricultural fields within sub-region 3C. And so we took that into account. And again, these volumes aren't that large on a watershed scale, but they're obviously important for Region 3C because they can meet a lot of the demands, which means they'll pump less within that region. I'll talk more about that shortly. So this is some results within Region 3. We've got the Miners Oaks Water District service area. Most of the demands are residential, and we meet those demands except in the drought years because we don't meet the full demands, the full agricultural demands in the drought years. The remainder of Region 3 is dominated by agricultural demands, and we assume there's enough groundwater pumping to meet those demands earlier in the modeling period, but there's not enough to meet the demands in the drought years. Looking at the overall balance, slightly more ag demands than residential demands in this region. Looking at the different supplies, this is where we see our surface water coming in. This is the surface water diversions to some kind of local crops. And then we see other supplies of water as well. Again, relatively equal pieces of the pie once you take out the surface water diversions. So again, even on this scale, the surface water diversions aren't hugely important, but for the ag wells or the pumping within the vicinity of the surface water diversion, it could have impacts, and that's why we included it. And that's it for this section. The next section, I'm going to kind of just recap the results and compare the bigger picture to other data sources. But we can take some questions here.
Thank you, Al. I'm looking at the chat. I'm looking for raised hands. Okay, we've got a first question. Area 2 from Brian Bondi. How was, I think it's Rancho Matilaha Mutual Water Company, RMMWC, diversions accounted for? And Brian, I think you have permission to unmute if you want to chat with us. So, Al, is that something that you can speak to?
Which diversions, Brian? Can you clarify a little bit?
Oh, let me give you permission to, sorry about that. Let's get you unmuted.
Hello, can you hear me?
Yes.
Yes.
Okay, yeah, thank you. So the diversion is located, I believe, it's hard to tell from the maps, but I think it's in the southern part of Area 3 or the northern part of Area 2. It's I can't tell you for sure, but they do operate a surface water diversion, and those records are included in the ERIMS data, and that water is transported to the area west of the river floodplain, north of Lake Casitas, and I believe it's in Area 2. So it's a substantial amount of water in some years.
Yeah, I'd have to check, but I think I'm reasonably sure that we saw that in the ERIMS, and I think we also saw it. This is diversion from the Ventura River, right, Brian?
Yes, it's logged
yeah.
as a surface water diversion. So what caught my eye was in Area 2, the pie chart showed no surface water. And,
yeah, okay. I believe that's included as a pump, because essentially they're pumping out of the river, so it's included as a well in our model. So that's a good point, because I remember we came across these kind of duplicate data sets.
Okay, I believe
Yeah,
it's a surface water right, and my understanding is they have a infiltration gallery, and so that it's a surface water diversion. But that's a detail, perhaps. I just wanted to make sure it's accounted for. Thank you.
That's good to know, and we'll double check. I believe we've got it in there as a well.
Okay, thank you, Brian. Next question from Christian Labor. Given that rainfall in water year 2017 was 125% of normal, why was this considered part of the drought period? Christian, I'm going to give you an option to unmute if you want to.
Yeah, I believe it was mostly predicated on the Lake Casitas surface elevations hadn't really recovered at that point. So a lot of the drought, contingency measures were still in place. And furthermore, the analysis that we did in Region 4 kind of confirmed that we're not meeting the demands in Region 4. So that's why we kind of carried through that analysis into the other regions.
Okay, let us know if you have any follow-up. Christian, any other thoughts, questions, comments? There's a lot of information presented there. Is there anything you want us to kind of go back and look at again? Christian adds, ag demands are typically lower in rainfall years due to rainfall.
Yeah, and we didn't have DWR applied water data for 2017. We would have relied on the correlation. I'd have to look back at that a little more closely. But I expect the demands were lower, but I think we still used a kind of drought reduction factor in those years, based on what we saw in Region 4.
Okay, Christian, please let us know if you want to follow up on that. We can come back to it at any time. I have a new question from Casey Walker. Hello, this may be a tangential question, but I want to ask, how might SGWA impact for residential wells adjacent to the Ventura River? Okay, Sustainable Groundwater Management Act. Is this a management question on how SGMA may impact residential wells adjacent to the Ventura River? Casey, I can give you the permission to unmute if you would like it. Got 2 Casey Walkers in chat. I'm just going to let them give both ask to unmute. Or there's only one I can actually. Hello?
Hello, this is Casey Walker, and I just had a quick question, and it might be tangential to the overall conversation of just kind of water bookkeeping, if I can say. But I wanted to ask, I'm a Ventura resident, and how might the Sustainable Groundwater Management Act impact water distribution and supply if I have a well adjacent to the river? So how might that act impact my water rights?
Good. Okay. Yeah, I actually, so that's actually a good question for someone, a staff person at the Upper Ventura Groundwater Management Agency. Brian Bondi is their executive director. He just posted his contact information in chat. So just to kind of clarify, this team, we're at the State Water Resources Control Board and the Los Angeles Regional Water Board, and we're working with our modeling team to develop a surface water groundwater model of the whole Ventura watershed. We are not implementing Sigma. The GSAs in the Ventura River watershed are implementing Sigma, and that's the Upper Ventura Groundwater Agency and the Ojai Basin Groundwater Management Agency. So if you have questions about how Sigma is going to impact you, I think Brian Bondi would be a good person to contact. Does that answer your question?
It does, and it gives me a contact to reach out to. Thank you so much. And I had another quick question, and I really apologize if it's again like tangential, but I wanted to ask. So Matilla Dam is a part of Ventura River, and I wanted to ask how taking down that dam may impact water supply to both agriculture, residents, municipalities. Sure.
So through this project, we're having Geosyntec, our modeling company, our consultant, evaluate 8 scenarios. The whole purpose of developing this model is that a major purpose of developing this model is that we can evaluate what if scenarios. And one of the scenarios that we want to evaluate is Matilla Dam removal. So once we have this calibrated model up and running, then we'll build some scenarios and look at results. And so one of those scenarios is the removal of Matilla Dam, and we'll look at how the removal of the dam impacts groundwater levels and surface water flows, impacts the water supply, where and when water is available in the watershed. Does that make sense?
It does make sense. And I'm curious to see those results in the future.
I agree. I'm also, go ahead.
I was just going to say thank you so much for your time, and don't want to take any more time from the podcast, or not podcast, the webinar.
All right. Okay. You're welcome. Thank you for the question.
No problem.
Yeah, we're all excited to see the scenario results ourselves. Any other questions? Anyone want to raise their hand to get unmuted or ask a question in chat? Any follow-up questions from things asked earlier? Any kind of thoughts or impressions on the overall approach? Okay. Has there been any effort to quantify the available groundwater volume from the aquifers in the region? Al, I'm going to let you answer this one.
I don't know if I'm the person, but yeah, there's been sustainability analysis done in the past. It's not really the scope of our project. We're trying to develop the model which could help answer that question, I think. But I wouldn't say it's the focus of our project to look at the volumes in the aquifers.
Well, I think it is part of this project to understand, understand how much groundwater is in the aquifers and how those groundwater levels interact with surface water.
The model, I mean, we had the geologic presentation a couple of weeks ago, and that's obviously part of it, into delineating the groundwater basins, and which obviously impacts the amount of storage they have in them, and then running scenarios to understand that if you take too much water out, how that can impact the river flows for sure.
Hey, Al, this is Greg Schnarr. Do you want me to also chime in here?
Yeah,
this is
please,
Greg Schnarr.
please.
Yeah, with Daniel B. Stevens, and we're subcontracted to Geosyntec, focusing more on the groundwater portions of this study. And the answer to the question is yes. There have been various previous studies, and one of them, for example, was the Stahl, Gardner, and Dunn study that you mentioned at the top. Was one of several studies looking at the amount of groundwater in storage in the Ojai Basin. Turner had some studies in the 1970s and looking at groundwater and storage in the Ventura River basins. And there are others. And I'd say the newer efforts run by the sustainability agencies, I'm sure, are looking at that question as well, and is the kind of information that could be extracted from any of the models that are in development or have been developed, including this one, to sort of update and revise those previous estimates.
Thank you, Greg. Okay. Any other questions? Okay. I think we're going to keep going then. Oh, are there going to be any climate change analyses done for this modeling work? Yes. So I mentioned 8 scenarios earlier, and we'll be talking a little bit more about scenarios at the end of webinar 3. But we are going to do a climate change scenario, and I think the idea, the way we're going to run that scenario is, or the way we're going to build that scenario is, we're going to take modeled, simulated projections for climate change and how climate change will affect temperature and precipitation in this watershed. And I think we're going to apply those projections to the calibration period, which is 94 to 2017. And we're going to see how, if those projected changes had occurred during the model period, how that would have affected surface water and groundwater. So yes, that is something we will be looking at as one of our scenarios. You're welcome. Okay, I think we should continue into the last portion of the presentation, and then after that we'll have the rest of the hour for questions and discussion, and we'll have a wrap up with at 11:55 with instructions for meeting recording, slides, and seeing the chat log. So thank you for these questions.
Great, thank you. Yeah, I think on the home stretch, there's maybe 6 or so slides left to kind of summarize the results and do some additional checks on the, bigger picture checks on the analysis. So this is, I showed it early in the presentation. I showed it 2 weeks ago as well. But this is kind of why we did all this work, is to estimate the annual pumping volumes for the non-measured wells within the watershed, and specifically the wells shown by these square symbols. For domestic, we just assumed 0.5 gallon per minute, but for the ag wells, we did this quite extensive analysis based on grouping wells with crops. We used the Casitas pressure zone data because where they send their water will obviously impact how much pumping is needed to meet the remaining demands. We also used the results of the UVRGA survey to tie specific wells up in this region to specific crop acreages, and we came up with these annual estimates of the non-measured wells that we can use to input into our model, modeling period of 24 years. It's kind of useful to, we defined our analysis by these regions, which was governed by the Casitas pressure zones. I think folk in the watershed and people on this call are more perhaps familiar with the groundwater basins. So we went step back and looked at our total pumping volumes by groundwater basin, shown here in the figure on the left, and I'll go through this with a little bit of detail. So the lower river groundwater basin is defined by this the red dashed line, and you can see the boundary between the lower Ventura Basin and the upper Ventura Basin is down here, whereas the boundary between our regions based on the pressure zones is further north. But we went back and you know, re-aggregated the pumping volumes within each of the groundwater basins. So in the lower basin, lower Ventura Basin, we see, you know, these are the total volumes pumped. I think it's about 500 acre-feet per year or so. In the upper Ventura River, so this is the basin all the way from, you know, that spans part of Region 1 as well as Region 2 and Region 3. We've got the estimates here in this crimson line. So quite large volumes. And again, this includes not just the ag pumping, but also the municipal pumping as well. And when we first got this line, I was kind of concerned because we had this precipitous drop in pumping from 2004 to 2005. And I was like, we must have, you know, made an error in our method. What have we done? So I went back and looked at the data a little bit more, and this drop is actually caused by a decrease in the municipal pumping, which I've plotted here in a dashed line. This is the total municipal pumping within the upper groundwater basin. And further research showed that in 2005, I think that was a very wet year, the wells at Foster Park were damaged, I guess due to flood impacts, and the city of Ventura couldn't extract as much water as they would have liked due to the damage. So that explains that trend. If we look at the green line here, this is the pumping in Ojai Basin up in Region 4. And then the blue line is Upper Ojai up here out in Region 5. So this is kind of what the pumping, the total extractions by basin look like. And you know, one reason we did this is because there's other estimates of these volumes that we can compare our results to. And this is what we did in these couple of tables. So in the Ventura County 2040 General Plan, they provided estimates and sometimes a range of total extraction estimates for the 4 different basins as well as for the entire watershed. The OBGMA also had estimates for the Ojai Basin, and we compared our current study to those numbers in this table. So I'll take a little time to go through this. So for the lower Ventura River, our current study, we estimated, you know, about a little over 500 acre-feet per year, annual average total pumping volume. In the Ventura County General Plan table, you know, the range that they provide is between 400 and 1,200. So we're well within that range, kind of on the lower end of that range. The upper Ventura River, we estimated an average of about 8,700 acre-feet per year. And this compares to about the 10,400 acre-feet per year provided in this table. We think our number's probably lower because of the drop, you know, the large reduction in Foster Park that happened during our modeling period would have lowered our average somewhat. Otherwise, it may have been, you know, more in agreement with this, but in either case, this is in pretty good agreement. For the Ojai Basin, our current study numbers agree very well with the OBGMA, and that's essentially because we used their data for our model. And then there's other ranges provided in the Ventura County General Plan, you know, between 3,000 and all the way up to 8,000 acre-feet per year, and we're within range of that as well. In the Upper Ojai, our methodology estimated about 1,300 acre-feet per year. The table here provide a range from 700 to just over 1,300, so we're within that range, kind of at the upper end of the range. And then if you sum all these kind of basins together, you get the total watershed extractions. We're about 15,000 acre-feet per year on average, which is kind of at the lower end of the range in the provided in this table. So these are the total extractions, total pumping in each basin. The other thing we can look at is the pumping that is used for agriculture, because there's information on that as well. So going through again, basin by basin, in the lower Ventura, we estimated about 500 acre-feet. This is in line with other estimates based on a demand approach as well as a rate-based approach done by D.B. Stevens in 2010. Upper Ventura, similarly, we came out with about 2,100 acre-feet per year on average, which is kind of on the lower bound of these, within range of these other data sources, kind of at the lower end of the range. And then the Ojai Basin, we got very similar numbers to the OBGMA, which is good. We didn't use these numbers directly in our analysis, because in our analysis we looked at the supplies, and then we moved those supplies around to the different uses, to agricultural or residential, to get our number, and they agree very, very closely, which indicates the method is appropriate. And in the Upper Ojai Basin, most of the 1,300 acre-feet of total pumping goes to ag, and we don't have an estimate to compare it with, but the residential pumping up there is very low. A final check that we made, the CMWD, in addition to publishing annual total deliveries, in many or most of the model years, they publish total deliveries to agriculture. Now, we couldn't use those numbers directly because they didn't really provide information on where in the watershed that water that went to agriculture went, but we can use it on the back end to kind of back check our method. So this plot here, it does that. On the horizontal axis is the published Casitas total ag deliveries in acre feet. So each data point represents a particular year in our modeling period. And on the vertical axis is our estimated ag deliveries. I've plotted the one-to-one line up here, and we are mostly below that line, pretty well correlated, and would expect to be below that line because this is only ag deliveries within the watershed. And if you recall at the beginning, I stated that the Casitas export to agricultural uses outside the watershed, particularly along the coast. So this kind of is a final confirmation, I think, of our method that our approach is reasonable. And then finally, we can kind of look at the watershed average annual demand simply by summing up the 5 different regions that we looked at. I think I showed this plot earlier, but about a third of it's residential and a third of it's 2/3 of the demands are agricultural. And then looking at the watershed-wide supplies, we can see that if you add the purple and the orange, a little under half is supplied by Casitas. This is on an average basis. And we can see that the surface water makes up a relatively small component. These are the surface water diversions. This does not include the Rancho Matilija diversion out of the Ventura River, which we treat as a well. And you can see that there's relatively equal parts of pumping for ag as well as Casitas deliveries to ag. And there's also quite a lot of pumping for residential, to meet residential demand, primarily through Miners Oaks, Ventura River Water District, and what used to be Golden State Water Company. And that's kind of the summary of what we've found. I think we can turn over to questions. Got about 25 minutes left. I think, Kevin, you wanted to finish a little before noon to kind of wrap up, but maybe 20 minutes of questions or something.
Yeah, I got just a couple of housekeeping wrap-up slides, but those can wait. What are people thinking? Please tell us. Okay. First question from Bruce Kubler. What methodology will be used to account for longer-term changes in water use implemented during drought and determining future water demand in model runs? Ventura River Water District gallons, I'm sorry, I don't know that one. GPCD is likely to stay in range of 130 to 150. Bruce, would you like to unmute to ask that question or discuss that with us?
Yeah, can you hear me?
Yes. Thank you.
Yes.
I just wondering, I noticed that they used a GPCD of 196 kind of as a baseline. And, you know, that doesn't reflect the fact that water use in our district has been reduced dramatically, 35, 40%. And most of those are results from people switching to lower water use vegetation and things like that. And we have an aggressive conservation program. So the GPCD is likely to be much lower in the future. I just wondered, how do you account for that when you're going to be doing your model runs?
I guess I got two comments. The first is the 196 was a baseline value that we then scaled with the kind of temporal trend from the CMWD. So that would have been reduced over the modeling period. I don't know if it got down to the 130 or 150 that you're talking about, but we can check that. But yeah, looking forward in the scenarios, I mean, that's a great point. And I think if you've got information, you know, especially, you know, we might look at a scenario of different conservation measures. I think using realistic projections from different agencies and providers would be totally appropriate. So to that end, anything you can provide looking forward can be considered in the scenarios.
Is now the time to provide that data or that information?
Sure, yeah.
Okay, thank you.
Thank you for that question. Anyone else? Other thoughts, impressions, questions, comments? Anything we were talking about earlier, you know, earlier questions that maybe you wanted to follow up on, or perhaps you wanted additional answers for? Has there been a trend analysis for land use change? Al, I think you can answer this one.
I wouldn't say we did a trend analysis. We did look at different data sets. We looked at percent impervious. I think the one we ended up using was, I believe, from 2011. I think the details might be in this data report we put out. We used 2011 percent impervious, and we did look back at, I think, 2001, so 10 years prior, and the changes were very small, especially from a hydrological perspective. In terms of crops, we looked at earlier VCAC data. There's also some DWR crop data that we looked at. I'd have to check, but I think we looked back at maybe 2003 or something, and there wasn't huge changes. And in terms of, you know, using it to develop the unknown pumping quantities, I think, you know, from a watershed-wide perspective, they're probably pretty minor. Clearly, if there's, you know, a specific field that is taken out of use, it may impact one well nearby, but from a you know, developing and calibrating a model perspective, it's probably not that critical. You know, we did look at it, and it appeared to be relatively small changes. Some of the scenarios could look at that. You know, if we change land use to things that have less intensive water use, that would obviously be important to consider.
Okay. Next question from Brian Bondi. How are you distributing annual estimated extractions within a given year in the model?
Great question. Yeah, I did focus on annual budgets for this talk. When we go to the implementing in the model, if it's a residential supply, we use some residential demand factors. that we looked at from, we got some data from State Water Resources Control Board to come up with residential demand factors, appropriate for the region. And for the ag, which is probably the more important one, because we looked at ET from our initial model runs to look at how that changes seasonally, which is a big thing, but also slightly different from year to year. Some years are a little hotter, some are a little drier, and we use monthly factors, which are slightly different each year, to apply both in terms of pumping water from the wells, and also we actually applied the irrigation water to the actual crops within our PRIMS, or precipitation runoff modeling system. So it was used in two different ways. And then for the larger producers, we often had monthly data as well that would have been used directly. But if we only had annual or semi-annual, we put seasonality on it based on simulated ET within the model. Does that answer the question?
Brian, please let us know if you have any follow-up. Okay. Okay, we can talk more offline. Okay. Got a question from Paul Jenkins. So to summarize, this was a calibration of supply and demand estimates, and the model generally falls within 10%.
I don't know if I'd call it a calibration. We developed a method to apply, primarily to apply to all the regions except for Region 4. And we also applied that method in Region 4 to kind of assess the accuracy, if you will. And I think we were, our demands, on average, our demands and supplies were within 11%, I think. But, so that's, to back up our approach. But I wouldn't say we're calibrating our model yet. We're doing this to develop the model inputs, primarily the pumping volumes from those non-measured ag wells is the big focus. Does that clarify?
Thanks from Paul. Okay. And Brian, I think we'll connect offline to discuss more if you'd like to. Make sure we understand your comment. Okay, any other questions or comments or thoughts, impressions?
Well, Kevin, why don't we do the wrap up slides, and then we can circle back and see if there's any more questions at the end.
Okay. I'm going to take the screen for a minute here. Nice job, Al. Thank you.
You're welcome.
Okay. Can everyone see this upcoming webinar's slide?
Yes, yeah, we can see it.
Yep.
Okay.
Yes.
So our next webinar is in 3 weeks. So not 2, but 3 weeks. On Wednesday, June 9th at the same time, 9 a.m. to 12 p.m. We'll be sharing calibration and validation results for the preliminary draft groundwater surface water model. We'll also be talking about our timeline, so next steps and how to stay involved. So we'll be talking about release of the groundwater surface water model, release of the water quality model. We'll be talking about scenarios. So please tune in for webinar 3. Thank you for all the questions that we've received. There's, I think, some of you that we're going to it sounds like we need to talk more offline with. So in general, we're doing these webinars to solicit technical comments. So please submit those by Friday, June 25th to the email address here. This is just the email address for my unit, the in-stream flow unit, the unit that I work in. If you asked any of these questions, we're writing them all down. So even if you don't submit comments, we still have these questions and we'll be considering them. So thank you. And so next slide, we are going to post, just like we did with webinar 1, a copy of the slides and the chat log in our FTP. So we have an FTP that we originally hosted for our technical advisory committee, and we're sharing that login information so that anyone here can go in there and download the slides and the chat log. And we'll also include a link to the meeting, which is on YouTube. So the FTP is, external users can download files from it. Has anyone, could I get some feedback maybe on how folks have been able to access that FTP and access that information? Not seeing any feedback. So yeah, that's where we're putting the slides in the chat log. And like I said, there's a link to the meeting. Also on our unit's website, we have all these deliverables that we've been mentioning, like the study plan, the GL memo, the data report. So on the in-stream flow unit website, which we'll post a link to in chat here, you can download our documents that we've published so far. And there's also a link to the first webinar on our website, and we'll have the link for this webinar will be posted by the end of the week there as well. So you can find the link to the meeting in either the FTP or on our website. If you need help with any of this, accessing any of this, just please contact me or any of the other water board staff and we can help you through it. Any questions on accessing any of this information or accessing where we are storing this information so that you can download it, review it, use it to help you fall asleep at night? Okay. So next wrap-up slide is just a repeat of our contact information and our unit's website. So you heard from some of us today from the State Water Board. We're working on this project with the LA Regional Water Board, and so these are all of our contact infos. And we're of course working with our great team at Geosyntec Consultants and Daniel B. Stevens and Associates. So if you need me to kind of go back to either one of these slides with the contact info or the instructions for the FTP so that you can take a screenshot, please let me know. That's all I've got. So is there, I can't really see the participant list right now. I don't see any questions in chat. Is there any, oh, I was able to download the files through the FTP for webinar 1. Thank you. Thank you for the feedback. I'm glad it's functioning. If anyone needs help with that, finding that, logging in, navigating it, please let me know. We're trying to make all these resources available to help folks understand our process and provide technical comments. And of course, you can reach out to us if you would like to discuss anything additionally offline. We're available to talk at length about questions, comments. We want to give you everything you need to provide us feedback, good comments. I think we're gonna probably I'll probably call the meeting pretty soon unless I get any other questions. Okay. Well, I thank you all for joining and for all of this feedback. And yeah, I hope to see you all at webinar 3. And I think with that, we'll call it a meeting, unless there's anything else.
Great. Thank you, everyone, and thank you, Kevin.
No, thank you.
Right. Yeah, thanks everyone.
Thank you for participating.
All right.
Okay, let's stop the recording.